Users could see the full SQL definition of a view, including sensitive table and column names. The developer assumed a standard view would hide the underlying structure, but it didn't. Let's explore. You'll learn how to create and manage standard views, secure views, materialized views, leverage result caching, and set up alerts in Snowflake. A view is a saved SQL query that acts like a virtual table, simplifying complex joins and aggregations across one or more base tables. It needs no storage of its own, it doesn't store data, it stores the query. When you query a view, Snowflake runs the underlying query and returns the result. Views are essential for security, simplicity, and consistency. Let's create a view that joins customers and orders to show a customer order summary. Once defined, you can query it just like any other table, simplifying access for analysts. This view aggregates order data per customer. Notice the left join and group by. You can query it just like a table. Standard views expose their definition to users with monitor privilege. Secure views hide the definition to prevent exposure of underlying base tables, protecting sensitive table names and business logic, and support row-level security. This secure view hides the salary column and filters out HR employees. Users can query it, but can't see the underlying SQL. Materialized views physically store query results and are automatically refreshed as base data changes. These pre-computed results then power fast, frequent aggregations, but that performance comes at the cost of storage and maintenance. This materialized view uses date-trunc to group orders by month, pre-computing sales by product. Querying it is much faster than running the aggregation. Snowflake automatically caches query results for 24 hours. If you run the same query again with the same context and no data changes, you get the cached result instantly, and it's all transparent, requiring zero configuration. Run the same query twice. The second run uses the cache. You can verify by checking the cached result column in query history. Alerts allow you to monitor conditions like high credit usage or long-running queries. They send notifications via email or webhook when conditions are met, and the schedule defines how often those checks run. This alert uses DATEADD and current timestamp to check every 10 minutes for queries over 5 minutes, then calls system$send email. This is the chain reaction that unfolded. The developer created a standard view to hide sensitive columns, but standard views expose their definition to any user with monitor privilege. Users could see the full SQL, including table names and column names. The fix was to replace the standard view with a secure view using the secure keyword. This hides the definition from users. Additionally, unnecessary privileges were revoked and row-level security was added. Using a standard view for sensitive data exposes the view definition, leaking column names like salary. Switching to a secure view hides that definition so users can't snoop on the underlying SQL. Materialized views don't support count, distinct, so attempting to create one with it triggers an error. Dropping the distinct and using a plain count lets the view build successfully. Result caching can return stale data if the base tables have been modified, because the cache is invalidated only after the next query execution. After an insert, a query might still get old results. The fix is to set useCachedResult to false in the session, which bypasses the cache entirely and always fetches the latest data from the tables. To debug issues, use these commands. Check if a view is secure with show VIEWS, monitor MV refresh history, bypass cache with alter session, and review alert history. Let's review common interview questions on this topic. Note that result caching has a 24-hour lifetime. To summarize, use secure views to hide definitions, materialized views for performance, leverage result caching, and set up alerts for monitoring. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.